Hello students, welcome back to our revision class. Today we are going to discuss on dynamics, Unit 4 for grade 11 physics. So we know that dynamics is a branch of physics that studies about motion with its cause, basically, okay? So basically in dynamics we are going to study about force, okay? So we know that force is a pull or a push that one object exerts on another object. So when we are talking about force, it involves at least two objects, as you can see. So the concept of force, we know that force is a vector physical quantity which needs to be expressed using both magnitude and direction. And we have four fundamental forces. There's a strong nuclear force, the weak interaction force, electromagnetic force, and the gravitational force, okay? So every force can be categorized under these four fundamental forces, okay? So the first part that we have seen on dynamics is about Newton's laws of motion. So Newton's laws of motion basically talks about forces. So the first law, as you know, it states that an object will remain at rest, and an object moving with a constant speed continues to move with a constant speed unless some external force is acting upon it, okay? So V is equal to 0 or V is equal to constant means in both cases the acceleration of the object is 0, okay? So there will be no acceleration unless there is no net force acting upon it. So this is the first law. Second law, if there is an acceleration, then the magnitude of the acceleration depends on two factors: the net force acting on the object and the mass of the object. So the greater the force, the greater the acceleration. The greater the mass, the smaller the acceleration. So acceleration is equal to force net divided by mass, or we can simply write it as force net acting on an object is equal to mass times acceleration. As you can see, it says resultant force or net force. That's the sum of all forces acting on the object, okay? So the third law states that for every action force there is equal and opposite reaction force. So if object A exerts a force on object B, which is FAB, then the second object will exert the same amount of force but in opposite direction on the first object. So as you can see, force in nature exists as pairs, action and reaction force. So these two forces are acting on two different objects, okay? So another concept on dynamics is about friction. Friction is a force that opposes the motion of objects, and it's always parallel to the line of motion of the object. And frictional force, there are two kinds of them. The first one is static and the second one is kinetic. So static is resistance force between two objects when they are at rest. Kinetic is when they are in a relative motion, okay? So basically, static frictional force, the amount of frictional force between two objects depends on two factors. The first one is the nature of the interacting surface. That means the smoothness or roughness of the surface. And the second factor is the normal force, okay? Normal force is the force that presses the two surfaces together, okay? And the normal force is always perpendicular to the surface of interaction. For if we put this box in a table, then the normal force is always perpendicular to the surface of interaction. So the frictional force is always directly proportional to the normal force. So frictional force divided by force of normal is equal to mu, where mu is called the coefficient of friction, which has a value between 0 and 1, okay? Between 0 and 1. So basically, since static friction is always greater than kinetic friction, a surface can have both coefficient of static friction and coefficient of kinetic friction. So the coefficient of static friction is greater than the coefficient of kinetic friction, okay? So this is all about frictional force. And the other concept on dynamics is about momentum. So you know that the first person who introduces the concept of momentum into physics is Newton. So according to Newton, the force that is required to stop an object from moving depends on two properties of the object. The first one is its mass and the second one is its velocity. So the greater the force is when the mass of the object is greater, and the greater is the force when the object is moving with greater speed, all right? So momentum is a vector quantity which is the product of mass times velocity. You know that a scalar mass multiplied by a vector velocity gives us another vector, which is momentum, with a unit of kilogram meter per second. Okay? So we can rewrite Newton's second law in terms of momentum. We know that net force acting on an object is equal to mass times acceleration. So net force is equal to mass times, we know that by definition acceleration means final velocity minus initial velocity divided by change in time. So we know that mass times final velocity minus mass times initial velocity divided by change in time. So the net force acting on an object is equal to mass times final velocity, final momentum minus initial momentum over time. This is change in momentum over change in time. So net force acting on an object is equal to the rate of change of momentum. So if there is no net force acting on the object, then there is no change in momentum. That means the momentum of the object becomes conserved. So momentum is conserved in the absence of net force, and we call this the law of conservation of momentum. Okay? The law of conservation of momentum. Then when we talk about momentum, it's important to talk about collision. You know that collision in physics is defined as an event in which two objects exert a relatively strong force on each other for a very short period of time. Okay? So we have two kinds of collisions. There is an elastic collision and inelastic collision. Inelastic collision or plastic collision. Okay? Inelastic collision. So this is a kind of collision in which both the momentum and the kinetic energy of the colliding objects are conserved. But in elastic collision, kinetic energy is not conserved. That means there is some kind of energy lost as heat in the process of collision. Okay? So when we say momentum is conserved, that the total momentum of the colliding object before collision is exactly equal to the total momentum of the colliding objects after collision. And when we say kinetic energy of the colliding object is conserved, then the total kinetic energy of the colliding objects before collision is exactly equal to the total momentum of the colliding objects after collision. Okay? But a special kind of inelastic collision, which we call in a perfectly elastic collision, the two objects will move with some common velocity after collision, so that from the law of conservation of momentum, m1 u1, m2 u2, this is the total momentum before collision, is equal to m1 plus m2 multiplied by v, where v is the final common velocity of the two colliding objects. Okay? So basically in dynamics we have seen some applications of Newton's laws of motion. So how to apply the laws of motion to solve some practical examples or problems. I hope you have them on your exercise book. So this is all about dynamics. Until next time, stay safe.